Alright, welcome back to our third video. We're going to talk about another type of graph we can use now for data. We're going to talk about a stem plot. So we have some steps we can think of when we're creating stem plots. The first thing we need to do is separate each observation into a stem, which is all but our final digit, and a leaf, which is the final digit. And when it's talking about stems and leaves, if we have a number like 143, right, our stem would be that 14 and our leaf would be the 3. Okay? Now, once we've done that, we're going to write the stems in a vertical column with the smallest at the top, and then we're going to draw a line on the right of this column. The important thing is to not skip any of the stems, no matter if there's a number or an observation for it or not. Once we have that, our next thing is to write the leaves in a row to the right of the stem, so on the other side of the line that we drew. And then we want to make sure that they're in order from smallest to largest. And then finally, we need to make sure we make a key. Right? We want to make sure people understand how to read our data. Alright, so now let's give it a try. We're going to look at a group of 20 females in high school who are asked how many pairs of shoes they own. So notice that all of our numbers here have two parts to them, just two numbers. So we can look at the first number as our stem and the second part as our leaf. So now that we have stems and leaves, we really want to look at what's our smallest stem. Well, we can do that by also looking at our smallest number, right? Our smallest number is 13, which means that our smallest stem is 1. So we're going to start by putting a 1 at the top. And we're going to count down, or count up, excuse me. So 2, 3, 4, 5, and I think 5 is the highest we get. So then we can stop there, and we're going to put a line next to it to separate our stems from our leaves. And now we're going to put our leaves in. So remember, we want to put our leaves in order from smallest to biggest. So our smallest number was 13. And notice that we have 3 13. So I'm going to put 3 3s in. Right? Then I'm looking for my next smallest number, which is 15. So I'll put in a 5. Right? The 1 is already over there in my stem. And then I'm going to have a 19, so a 9. Next, I'm looking at my 2s. So the smallest 20 that I have is 23. So I'll put a 3 in. And I'll keep going this way. So I'll put in another 23. Oh no, I missed a 22. So let's go in and fix that. So I need a 2, 2 3s, a 4, and a 6. Notice that I have each number approximately in the same width as the other numbers, right? So this 2 and this 3 here both take up about the same amount of space. That's going to help us later in describing our distributions, so I suggest you try and work on that. Well, go ahead and finish your graph, right? Fill in your 3s, 4s, and 5s. Notice now that the last thing we're missing is our key. We want a key to tell people what to look for. So off to the side here, I'm going to write a key. And to write my key, I'm going to start by picking a number. And it can be any number that we have in our graph. So I might pick 22. And I'm going to say that 22 shows up in my graph. So I'm going to say 22 equals 2, line 2. Right? So that they know that 2 line 2 is a 22 pairs of shoes. Right? The reason we do this is because sometimes we might say 2 line 2 equals 2.2. Right? And it's okay to do that as well. But in this case, we'll say that 2 line 2 is 22. So one other thing we can do is called splitting stems, right? We can split stems to make the graph easier to read when there's too many data points on one stem. So when we split stems, we're putting two identical stems on the left side. So instead of just writing the stem 1 once, we're going to write it twice. And then the first half of our leaves, so all of the leaves from 0 to 4 will go on the first stem, and the second half of the leaves, so all of the ones from 5 to 9, go on the second stem. So if we were doing our stem splitting, we would put 1 and then 1 again, 2 and then 2 again, right? And we do this all the way down to our 2 5s. Just like normal, we'd put our line in. And then we would put in our stems, and for our tens numbers, right, our 3s would all go in the first spot. But our 5 wouldn't. Our 5 would go in the next one, and our 9 would go in that one as well. Right, this just helps spread out our data a little bit and make it look a little bit nicer if we have too much. Right, and we can continue that all the way down. The last thing I want to talk about is called the back-to-back stem plot. Right, a back-to-back stem plot is really nice when we're trying to compare two sets of data, but that are measuring the same thing. Right, so we could be looking at scores on an exam, right? But we have two different classes that take the same exam. So we have Monday's class and we have Wednesday's class, right? So now we can look here and see that we have a normal stem plot when we look this way, right? That's just Wednesday's class scores in a normal stem plot. But we can also show Monday's by looking the other way. It's kind of just flipped backwards. So notice that our smaller numbers are closest to the stem. Our smaller leaves are closer to our stem, even though it looks kind of backwards to us. And the reason we do that is just a little bit easier to compare, right? It's easier for us to notice that we have these outliers out here than if we are looking in any other way. So back-to-back stem plots are usually useful when comparing data.